My name is Hunter now, and this is my graphical user interface project for Engineering 204, Introduction to Programming for Engineers. Right here, so this is my figure. So we have 4 inputs, 3 of them being edit text, and then one of them being a pop-up menu. Then we have the push button, and then we have 4 outputs and the graph. So if I come to my main code right here, I have the main graphical user interface code. And then when I go down to the bottom here, I have the input section. So this right here, these 3 all are grabbing inputs from those 3 edit text boxes. First one being for the cruising altitude, second one being for the distance, and the third one being for the elevation. Then right here for the pop-up menu, we have the plane. We have 10 different cases for all 10 planes. CP is the speed of the plane. So each plane has a different speed, and we use that speed down here in time. So we take the distance and we divide it by the speed to give us their time, and then we multiply that times 60 to get us our minutes. Then we have the default descent rate and ascent rate, which was default descent rate was 3,000, and then negative 3,000, and then the ascent rate was positive 2,000. And then they were just both displayed right here as outputs. And in the output section, we have starting minutes, which was 0. Then we created a Y and an X array for the ascent rates. So for the Y-axis, we created it from the elevation up by 2,000 feet per minute all the way up to the cruising altitude. For X, we created it from 0 minutes every minute all the way up to the cruising altitude. Then for the descent rate, we created, the descent rate was negative 3,000 feet per minute. Final altitude we were aiming for was 0. And then the duration of descent was, to find that, we took the final altitude and we subtracted it by the cruising altitude, and then divided it by the rate of descent. And then for the time the descent begins, we took the minutes overall and we subtracted that minus the duration of the descent. Then we created a for loop here, and this was for, ARY was the ascent rate for the Y axis, which this loop creates only ascent rate values. And then we created it for the X axis, which was ARX. Then we put we created 2 vectors, a T and an A, and T being for the X values, and this inputs both the ascent rate values, and then it also combined the descent rate values for both of these. And then A was for the Y values. Down here we have the graph, and we've just plotted T and A. So if I run the program, we're just going to put 30,000 as our cruising altitude, and then we're going to put 357 as our distance, and then we're going to put the same altitude as it is at the Green Bay Airport, which is 695. So then we're going to go to the CRJ200, we're going to press calculate. So as you can see, it gives us our cruising speed. And then right here, our flight time is 46 minutes, and then these are always the default values. Now if I were to change it to the Boeing 777-200, as you can see, the values changed right here. Now we can also change the distance again. They're going to change it to 400. Actually, we'll change it to 45. We'll hit calculate, and then as you can see, it changed the values again. And then it does change all this time and speed based on different planes. So some planes are slower, some planes are faster. And so most people will use this to help calculate what the fastest way is to get somewhere using a different type of plane, and as for their ascent rate and descent rates. And that was all for my project. Thank you.